Hi, I'm Ron, and this is Tech Tips and Fixes. Today we're going to be looking at a repair video that I made quite some time ago. And this is the repair of a small guitar tuner. Not a very expensive piece of equipment, and possibly not even worth repairing in some ways, but I thought I might as well give it a try, and this is what happened when I did. This guitar tuner started giving me trouble the other day. I was tuning up before I played at a function, and plugged in my guitar, turned it on, and the lights just started flashing. I thought the battery was dead, and so I got a 9-volt battery and put it in it, and it did exactly the same thing. And in fact, when I started playing with the switches and just trying to find out what was going on, it seemed like it was intermittent. As I moved it around and tried different things, it started working intermittently, and so I was able to use it. But I brought it home afterwards, and it's actually not working at all. You can see the on-off switch, and I got no lights whatsoever. And so the fact that it was kind of cutting in and out, I thought maybe this could be a fairly simple problem. So I'm going to turn it off and open it up here. It's just got one little screw in the back. There it is, the printed circuit board with the components on it. So one thing that's really a handy tool to have is one of these magnifiers with the light built into it. As you're looking at it through the magnifier there, if you look right here, I'm going to point with my screwdriver, there's a connection there that actually is part of the connection of the input jack. And I looked at that very closely under the magnifier, and it looked like that jack, or there was a cold solder joint there on that connection to the jack. And so I actually heated it up and put some flux on it and just fixed that joint, and I thought for sure that I was going to have solved the problem. So I reconnected the battery, and nothing. So I took the board, and I thought, okay, it's completely dead now with the battery connected. Turn on the switch, and no lights whatsoever. And so I figured, okay, the first thing we're going to have to do is just make sure that we are getting power to the board. So I took a look at where the two leads from the battery come onto the board, and using my old Fluke multimeter, there you can see it, I checked on the terminals where the black and red wires from the battery come in, and I have 9.42 volts. The next thing I did was just basically did a little bit of tracing on that board to see if I could figure out where it went. It stands to reason that that power goes from those terminals through the on-off switch and then onto the board. And so if you can actually kind of see that there, tracing the wires, I traced them around the edge of the board to the power switch here, and then I checked to make sure that power was getting through that switch. And I could see it coming into the switch, 9.42 volts, and I could see it coming out of the switch, 9.42 volts. So I then traced that, and this is not easy, but you get better at it as time goes on. I traced that trace back, and that one came back to a pad over here, and again a pad here, which was on one side of a semiconductor device. I'm going to try and zoom in on that semiconductor device. There. device is the black device. Turns out it's this device here. It looks like a little TO92 package transistor, but it isn't. What it is, it's a little voltage regulator, and if you bend the thing over so you can see the front of it, it's pretty hard to read on video. You can see there's some writing on the front of that device. And even though you may not be able to read it on the video, it says 78L05. 78L05 is a low power voltage regulator. The 05 means that it's a 5 volt regulator. And so it regulates the voltage, the 9.42 volts from the battery down to 5 volts for use on the board, because a lot of equipment uses 5 volts. So the next job was to then find out, we know voltage is getting to that regulator because I measured it. Again, I'll just check that. So I'm going to put my black lead on ground. I'm going to measure the voltage going to the input side of that regulator. It's coming from the switch, so I know that's the input. And there I get 9.42. Then I look, it's a 3-terminal device. I look on the middle terminal, and I look on the outside terminal on the other side, and they all have 9.36 volts on them. So there's something wrong there. It should have, on one pin, it should have 9.42 volts coming in. The other pin should be ground, and that's typically the middle pin, I think, on a 7805. And the other pin should have 5 volts on it to regulate it down to be used on the board, but it's not working right. So there's either a problem with the ground or there's a problem with the device. The device might be shorted out, but the fact that there's no ground connection on one of those pins is a bit of a red flag there. So I'm going to investigate further. Okay, so I've managed to get a little closer shot of this board, and as I was saying, we have the black and the red leads coming in on the other side of the board, and they're coming in here, and there's where the black, which is the ground, connects to, and the red connects to here. And so the black and red, the 9 volts essentially, connects all the way over to the switch over here, and then it comes back to the 5 volt regulator, which is right here. The 5 volts actually comes in on this pin right here. This middle one is ground, and this other one is the output. Well, so this ground, when I measured it from ground to this pin, I was getting 9 volts, so that's not right, because that pin's actually connected to the ground plane of the whole circuit board here, if you'll notice, and that runs all the way back to this point here, which is part of the jack, the power jack, because you can plug these into a wall wart. So you'll notice, if you look real close here, that that pin, which is connected via a trace over to here, and then that connects to the ground plane. That should be one connection. There's no way that there should be 9 volts over on this pin over here, because that's all one connection back through there and around to here. So I looked more closely, and it turns out that if you look very closely to the trace right here, there appears to be a crack in that trace. I can actually butt up against where the crack is. So what I'm going to have to do is take a little X-Acto knife and scrape off the covering on the board and make a little solder joint there, connect that together, and I believe that's going to start working. And so I'm going to have to scrape off the little paint material and solder that right there. I've taken a small screwdriver. You could use an X-Acto knife or a jeweler's screwdriver, And right down in here I've scraped off the green paint on top of the trace because I believe there's a crack right there. It's pretty hard to see, but I'm going to solder that. I'm going to put some solder flux right on that point there. Or basically need to bridge the solder onto the across the break in the printed circuit board. So I've checked the solder joint and turned it on, and also used the meter to check to make sure, and I did have 5 volts out on the 7805 regulator, and everything is working. Actually, you can see the lights blinking there. This has got a microphone on it, so you can actually check to make sure it's working by just whistling into the mic. You can see the lights switching off and on. So, it's fixed.